For question 1, our experiment is within a game, the participants need to guess the number of marbles in a bottle. So this kind of experiment, we have only two outcomes, right? Either you guessed it correctly or you guessed it wrong, right? So we have two outcomes. And from the previous videos, we've learned that if we want to find probability for experiments that have two outcomes, we are going to use binomial distribution. Alright, so here they're also given us the probability of guessing correctly, but the probability is P. Okay, so in part A, we need to find two things. The first one is the value of P. The second one is the number of guesses if the mean and the variance is these two numbers respectively. Alright, but before we solve the questions, let's determine our X first. Right, so our X is our point of view or the thing to focus on. So in the question, it tells us to find the probability of guessing correctly, which is one of the outcomes. So why not we change our focus? Sorry, we set our focus where X is the number of correct guesses, okay, instead of wrong guesses. So if you're confused on which point of view you're gonna set for your X, a hint is you can actually take from the probability given in the question. So let's say the probability given here is probability of guessing correctly. So my point of view here would be X would be number of correct guesses. Alright, so recall back the formula for mean and variance would be NP and NPQ respectively. So here we can form two equations. So mean would be NP, which is equal to 36, and variance, which is NPQ, equal to 14.4. Okay, so I like to clarify that the number of guesses here is referring to n. Okay, so here we need to find two things. One is P, one is n, which is in red here. Okay, so now we can do substitution, but this is not our typical substitution, right? Because here, usually when we substitute, we will only use one unknown to substitute, right? But here, what we can do is use two unknowns together to substitute inside the equation. Because here, the variance, we have NP, which is the formula of mean, which is NP. So what we can do is straight substitute NP with 36. And once substituted, we can just find the value of Q by moving 36 to the other side, which is 2 over 5. Okay, so this is not the unknown that we want, but it's okay because Q and P, there's a relationship, right? P, which is the success probability, and Q is the failure probability. When you add them up together, equal to 1. So to find the value of P, we just 1 minus the failure probability. Okay, so our P is 3 over 5. And once we have P, we can substitute back here, find the value of N, which is 60. And the second question, it says that this participant can do 8 guesses and we need to find the probability that 4 of them are correct. Right, so here to find probability, we can use the formula, which is this one. Okay, so here our number of success would be 4. Right, so for the R here, I will just put 4. Then here equal to n. N would be the number of trials. So this participant can have 8 chances. So our n would be 8. Okay, and here will be followed by C4. P will be the success probability, which is 3 over 5. And this success we need to have 4 times. So we need to multiply 4 times. And the failure probability, which is 2 over 5. This one, because 8 guesses, we need to have 4 correct, so means 4 incorrect as well. So here 8 minus 4. Okay, then we can just put this into the calculator, then you'll get your probability, which is 0.2322. Right, so what if I change the question a bit? Let's say here becomes incorrect, and here I change to 1 of them. Okay, so now the probability is that 1 of them are incorrect. So how do you start off with the probability that we need to find? Okay, I'll let you all have 5 seconds to think about this. So the number of success here should be 7, right? Because recall back, X, our point of view is the number of correct guesses, not incorrect guesses. So if you put 1, means you are contradicting your point of view already, because here we are focusing on correct guesses, right? So here we have 1 incorrect, so this means the other 7, which is 8 minus 1, 7, must be correct. That's why here will be 7. Okay, so for the formula here, for the details of the formula, here will be 8C7, because we need to have 7 success, 3 over 5, probability of success, multiply 7 times, because we need to succeed 7 times. Then probability of failure, this one we need to multiply 1 time, right? Because one of them are incorrect. And then you can just calculate this one into a calculator, then you'll get your probability.